physical quantity and dimensional formula. Physical quantity and dimensional formula. So we were doing the magnetic field induction, and that is what we did. Now there is something very interesting is called permeability of free space, and the word permeability of free space we represent by the symbol mu naught. How we read? Mu naught. So we want to derive the dimension of this particular unit, which is of great use for me, interest for me. So this to derive this formula, we have some formula at our disposal. We can use it easily. So this is the formula called magnetic field developed inside a infinite solenoid. It's called magnetic field induction inside infinite solenoid. So what we are supposed to do is we have to use this formula. What n represents, I need to mention what is n. N is called the number of turns of coil per unit length of solenoid. So you may be wondering what is solenoid. Solenoid is a kind of cylindrical coil. So we wrap a large number of turns of a coil on a cylindrical hollow object, and we say it as solenoid. So the n is called number of turns of the wrap which you make of the wire. So we write n equals to capital N upon L. And I is the current. So I think that's easy. So you know the B dimension because we did in the last class. You know the current dimension. We know how to write it. Now you can find n. So can you tell me the dimension formula of mu naught?
Sir, M L minus 1, T minus 2, I minus 2.
So m L minus 1, T minus 2, I minus 2. Very good. So I think this is slightly different from what I have. Just check the L part. I think L part something is missing. Just check the L part.
Sir, L minus 2.
Or L. No, that is not coming. I think L plus 1 should come.
Sir, L0 should come, no?
Okay, I don't remember. So let me derive this because I always prefer deriving it. So it's n. N is having dimension. What is n dimension? L minus 1. Have you used this one? Because n is the number of turns per unit length. So it's inverse of length. L minus 1. And what was the B formula? B we did in the last class. No? M L0 T minus 2, I minus 2, I minus 1 actually. So this is I minus 1. M L T minus 2, M T minus 2. So tell me guys, what was the B value in the last class? Tell me B. M.
L minus 1, T minus 2, and I minus 1.
Okay, this is the L. B. Okay. And what is N? L minus 1. I is A, that is I into T. Current is, current is I1. Oh, charge is I into T. So what we are getting is M L0. Yeah, this is what we got. The dimension of this is ML0 T minus 2, I minus 2. Okay, that's correct. Now something very interesting. I mean, here I would like to just discover. Okay, something very interesting. Can someone tell me the dimension of this? Or tell me the dimension of this value, because now you know both, so you will have some answer to this.
Sir, it is under root.
Yeah, under root. Yeah, correct.
Sir, M is 1 by 2, L minus 2, T0, A0, and I minus 1.
M, how much?
M is 1 by 2,
Okay.
L minus 2,
Mhm,
T0,
mhm.
A0,
What is
and
A?
I minus 1. Sorry, A is, A is 0. Sorry, A is 1. Sorry, A is 1.
What is A? What is A? Current? Ampere?
Yes, sir.
So you
No,
mean just check the dimension of epsilon naught. Just check.
Sir, M should be 0.
Yeah, yeah, right. M should be 0. And T should have some value. T is not 0.
Sir, T should be, if it's,
T should be how much?
T should
yes,
be
T is
2.
T is 2.
T
And then
is 1. T is 1.
no, sir, T is 1 minus
T
2.
T, I think T should be 2 only. And the power is
Sir,
half, right?
after whole, sir, after, yes, sir.
After taking the root, you're saying the answer?
Yes, sir. After taking the root. So, sir, after taking the root, M0, L minus 2, T0.
Okay. So something is wrong then. Then this is not right. Something is wrong.
L
So
should be by 2.
yeah, so I need to check the dimension of
L
this
is
thing also.
minus 3.
Okay, okay, mu naught is ML0 T minus 2, I minus 2. What was epsilon naught? Tell me.
M minus 1, L minus 3, T4, I2.
L minus
3,
okay.
T4,
T4.
I minus I2, sorry.
So when this will cancel out, this will cancel out, and
L minus 3, T2.
so I think L is missing here. Here L, what you are saying is it's not zero. Something else
Sir,
should come.
sir,
Okay.
M0, L minus 2, T0, and I0.
Just wait, just wait. Here I think you have made a mistake. So to find the B formula, okay. What was the last derivation? Can you see the last example and tell me the answer of B? Else I need to derive this again.
M, L minus 1, T minus
B
2, I
is M,
minus 2.
L,
M L
and
minus 1 T minus 2.
I minus 1.
Okay, then this is L minus 1. Okay, and this I. Okay. And what is the epsilon naught?
Epsilon naught is M minus 1, L minus 3, T4, and I2.
Yeah, T for I2. Yeah, correct, correct. Yes. Okay. Okay, so somewhere here is the mistake. Okay, I think you guys are not. Something is wrong here. So B is IL ML T minus 2 IL ML0 T minus 2. Okay, so B is this much. Okay, so that's why this is a mistake. It is ML0 T minus 2 L I minus 1 upon L minus 1 for N and the I. So mu naught dimension is ML T minus 2 I minus 2. This is the answer. That's why I'm saying you have made some mistake here. So okay.
Sir, so answer will be M0,
Yes,
then L will be minus 1,
minus 1.
and T will be 1.
So you're saying after taking the square root or without the square root? First of tell me that.
After taking a root.
Okay, so let me do this. Okay. There's some mistake there also. So we have mu is MLT minus 2 I minus 2, and epsilon naught was how much? Once again, M minus 1 L minus 3 T power 4 I square, right? And minus half. So M will cancel out. We'll get L minus 2 that I can see. T square. Okay, so we can see the T square also. And then rest is okay gone. Minus half. So we'll what if I multiply minus half, I get a plus 1 and minus 1. Right. So what we are getting is called the dimension of this. What we will get is called LT minus 1. And this is nothing but the dimension of speed, velocity, right? So it's LT minus 1 is the velocity of dimension of velocity. So what you will know or realize that this is nothing but the speed of light. So the speed of light having this dimension, and basically the value of mu naught and epsilon naught, if you substitute, you'll get the nearest answer of light, which is 299. Okay. So normally we remember this way, that 1 upon under root of this is always a dimension of velocity, so that we can use it to find the dimension of one other. So if you know the mu naught, you can find the dimension of other using this relation quickly. Okay. Instead of deriving both is a more difficult task. So this is a better way of doing it. Okay. So this is called speed of light. And because of this relation, we say the light speed is electromagnetic. So light is an electromagnetic wave because it depends on the electrical and magnetic property. Okay, of vacuum. This is the vacuum property. So C is the speed of light in vacuum. Anyway, so this is very interesting one, which you should remember, that C is equals to 1 upon mu naught epsilon naught. Okay. So what next? Okay, so something is called Rydberg constant. You know, anyone have heard this name? Rydberg constant. This is called Planck's constant.
Yes, I've heard about Planck's constant in de Broglie hypothesis.
Yeah, correct. So in the de Broglie, which you learned is correct. So the Planck's constant is we denote with a small h, and we write energy equals to E into nu. This is called frequency, and h is called Planck's constant in the honor of Sir Max Planck. And this is called energy of photon. So we all know light is made of photons, and every photon will have a discrete packet of energy. It's like water in a balloon. So water is also continuous thing, but in a balloon it's a fixed packet. So energy is also continuous, but energy in a packet is just like a water in a balloon, and that balloon will have this much energy, which is proportional to frequency and equals to some constant, which is called Planck constant. The value of h is 6.626 10 raised to power minus 34 joule second. So now I think dimension we can find from here directly. What is the dimension of h? And Rydberg constant is also very interesting. It's a inverse of lambda. So 1 upon wavelength is written as Rydberg constant. This will learn in Bohr's theory in atom. So
Sir,
what is the dimension of
ML2 T minus 1.
ml square t minus 1 is the right answer. Okay. And dimension of Rydberg constant. So these are number n and m are numbers. So their dimension is basically, so nothing to do with this part. So we can just relate this to this is inverse of length. So it's L minus 1. That's it. So Rydberg constant is the way to express the wavelength when an electron, jumps from the high energy, let's say orbit number n. So when we have the orbits in atom, we have a nucleus, and if the electron will jump from here to the lower orbit, let's say m to n, then the proportional to the difference of energy, some photon will be emit here, and the photon which will emit in this case is like so it is like, you can think this way, the electron will suicide, and this is the soul of the soul, for the electron, and this is the energy of the soul. So electron will jump and it will release the energy, which is equal to the gap of the two orbits. And this energy will have some frequency, and depends on the orbit number. So this is how the Rydberg constant comes into place. It's very interesting. So now there are four constants which we would like to just focus, especially in this chapter, 4 or 5, whatever. So these are very difficult one, challenging one, like mu naught upsilon. Okay, I like better using different color. So mu naught epsilon naught, Boltzmann constant, Planck's constant. What more we need to know? Universal gas constant, Rydberg constant, and what else we need to know?
Coefficient of thermal conductivity.
Yeah, you can say resistivity and all those things. But these are like the most basic constants. These are constants. So what you are saying is also constant. But these are like fundamentally these are fundamental constants of nature. But what you are saying is the constant of a material. It's like will change from material to material. So that is a specific, I mean, constant. This is called universal constants. Okay. One. That's why I was missing one constant. That is capital G, the universal gravitational constant. Now, the physics, every problem of JE advanced or JE mains, which will come the difficult one, they will try to exploit these uh, fundamental constants. These constants are very important because these are called dimensional constant. It means these are constants with dimension. There is something called dimensional constant. So you must have the idea that what we can do to get the answer of these things very quickly. Okay. So what formula we should know so that we can find the relation as fast as possible. Okay. So every formula here which I have written. Okay, one more constant which I just derived, the speed of light. So this is the most basic and fundamental constant which you are supposed to remember to solve any challenging problem, like any question which will come across, especially the J advanced. If you look at the question of J advanced, they ask question very easy, but because the lack of awareness of these constants, it's very difficult to for in the assumption to get it clicked. So what you need to supposed to do is Reynolds number is also not considered here because that is again is specific to the tube, okay, a cylindrical tube. So that is not fundamental constant, and Reynolds number is dimensionless. Okay, so we are talking about the dimensional constant. Okay, so these are dimensional constant, and now we'll do some problem in which I will show you how to do the manipulation. Okay, what to think actually. Okay, so okay, so I'll give you some sort of kind of trick to remember this formula quickly. So for everything, I will write one formula. So C I just gave you. So remember this formula. Okay. So I'll give you something called energy density. If you remember the energy density formula, energy density we write as this way. So you may be asking, so what is E naught? E naught is called electric field intensity. So dimensionally, it's very simple. The electric field is nothing but the force upon charge. Dimensionally, they are same. So this was, I think I have missed somewhere, so I need to mention this. And then for Planck, this is the best form, the most basic. This is the energy equals to h nu. Okay, so that's you just got the answer, energy formula. And for universal gas constant, it's again the unit of the universal gas constant itself is the formula. The Rydberg is again to find G, Newton's law of gravitation. Just use that one, and that's done. C is meter per second. It's a speed of light. So anyway, if you know these formulas more intrinsically, you can actually get to solve some of the most challenging problems. So I'll just give you one problem. So it's all about doing the right kind of manipulation. Yeah, one more thing I will mention: the Boltzmann constant. Again, it's energy equals to, so dimensionally the product of my, I'm not giving formula, mind you, these are not formula, these are the dimensional formula. It means they are only the correct dimensionally, not physically. So when you multiply Boltzmann constant with temperature, then what you get is called energy. Dimensionally, this is energy. Let me write it properly. So now these are things which we should remember. T is called absolute temperature. I hope you have heard the name absolute temperature. It's a Kelvin, right? So when you measure temperature in Kelvin, we say absolute temperature. When you measure in degrees Celsius or Fahrenheit, it's called just temperature in degrees Celsius or in degree Fahrenheit. We don't use the name degree for Kelvin. So we don't say degree Kelvin. We only say Kelvin. In America, saying degree Kelvin is like a blasphemy. It's like you will be getting some kind of punishment if you are a small kid and saying degree. So degree is not allowed. Okay, you can't say degree. It's like you're hurting the sentiments. Anyway, not in America. It's in where is it? England. Sorry, in England it's very bad. You can't say degree Kelvin.
Sir, can
So,
you show previous page once?
yeah, sure. So now these are like very useful things that we need to know. These are fundamental constants in physics, and our life will be circling around these constants, these definitions. We are not going to learn something great apart from what we are discussing here. So something here and there we'll learn. Okay.
Sir, over here in the right column, the third last thing you have written.
Third, last, okay, one, two, this one.
Yeah, what is F and Q over here?
F is force.
Okay,
This is charge. Charge.
okay, sir.
Okay, mention
What
this. And this is energy density. Energy per unit volume. So let's say I'm giving you a question like this. Find the dimension of this. So do it by common sense. Find the dimension of this. You also don't tell me, then I will solve. You can match your answers. So whoever gets first, you can just name it. I have got the answer. So I hope you know the meaning of the symbols. Mu naught, epsilon naught, kb, T is for T is the absolute temperature, of course. Because I'm writing a formula. I'm not writing dimension. I'm writing a formula. So in formula, the capital T represents temperature in Kelvin.
Sir, I got it.
Okay, so you can share with on my WhatsApp.
Okay, sir.
Yeah. Because I want all of you to get the answer.
Sir, I also got it.
Very good. Send it to me.
Sir, I have sent
Okay.
it.
Okay. Yeah. I have received from Harshit and only Harshit. Oh yeah. Yeah. I received one more. Yeah, yeah. Right, right. Theta. Yes, I think theta minus 1 is yes.
Hello, sir.
Sir, you are on mute.
Okay, yeah, yeah. Okay, who has got this answer? Anyone got this answer?
Sir, I got it after.
Sir, I got this, but I didn't got theta.
Okay, okay. So now the idea was not to solve this question. The idea was that when you see so many symbols, then do not jump to the fundamental formula to solve. Try to segregate in order to make it something easier and then substitute the dimension. Because in examination, if you actually to try to do by the very basic method, like deriving all the basic, then putting it to it, it's really lengthy process. We have to somehow remember certain tricks which can help us in solving the, because very recently, maybe 2 3 years back, JEE asked a question of a dimension, and no student actually attempted that question because it had 4 options, and you need to check all 4 options for the correctness. So it was multiple choice question correct. So if one is correct, it does not mean other are incorrect. You need to check all 4 options. and it was really lengthy in terms of basic derivations. But there was a trick. So you can actually regroup the values and you can actually see the dimension in no time. So those who were able to see that trick, they were able to do it easily. Rest struggle to find the right answer, although it's a very easy question. So sometimes which something which appears very easy, you need to be very smart to also make it actually easy. Okay, so let's go to the next thing. That is
Sir, but how the theta came?
the temperature. This is temperature. So we write temperature as theta, na? Not T. T is for time. Here T is temperature. This T is temperature because this is a formula. In dimension for temperature, what do we write? We are substituting the dimension, right?
Sir, what was the formula then?
Pardon?
Sir, what was the formula?
So what temperature? Formula of what? Tell me.
Sir, what
Kiska
was the
formula?
question? No, sir.
Question of-
KB is just energy.
Yeah. Question
KB
was
is
the find,
just
find the dimension. Question was find dimensional formula of this value. Where T is temperature, these are symbols. This was the question.
Sir, please will you give one more very tough question in the same topic?
Okay, sure, sure. I'm going to give you a lot many questions like this. Okay, so this question is just a moment. Okay,
Sir, but it is KBT2, no?
just a minute, just a minute.
Sir, I had a question.
Yes.
So the dimensional constants you gave, do we have to learn the dimensions of them?
No, you need to learn the derivation, how to arrive at the answer using some basic formula. Like not all, because see what will happen is you need to remember something, the basic on the mechanics part. But as we learn more and more chapters in physics, those formula will come again because of course those are chapters. So when you will learn the chapter, then those formula will become part of your memory, and then you have to remember because dimension questions will be coming in the actual examination after the completion of the syllabus, isn't it? So that time, of course, you need to remember all those things, and by that time you will anyway remember because by that time you will be learning all chapters. So right now it's difficult. Right now you can, I mean, I will not say that you need to remember everything. So right now, if I am giving you a tough question, then I'll mention the dimension. I will mention the formula. Let's say I will give you find dimension of this. Use this formula or use this formula. So I'll give you formula, and then I will expect that using the formula you should be able to derive it. Understood? Okay, 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 okay. So now this. Hmm. Hmm. So this. Just a moment. Hmm. ठीक है. Can you find the dimension of this? All symbol will have the standard meaning. So you know what is H. H is the Planck's constant. T is the temperature. G is the universal gravitational constant. M is the mass. H is the Planck constant. Kb is the Boltzmann constant. Try doing it smartly.
So done.
Done. Very good.
Yes.
So just keep for one more minute. Let others also attempt. Then I'll start writing it. Are you guys trying it? Everyone?
Yes, sir.
Okay, very good. Go ahead.
Yes, sir.
I want you all to learn and actually participate in answering question in class, because if that habit is not developed, trust me, the performance will never improve. So in class, solving is more difficult than actually solving at home.
Sir,
Try
done.
solving. Done. Very good.
Done, sir.
Very good. Okay, so let me check.
Sir,
So yeah, so H is very easy. H is energy upon energy into time, right? So M L square T minus 2 minus 1. Yeah, energy this much. So H is done. Done, understood. KBT is energy again. So M L square T minus 2. And then T is temperature, so theta. No, this is interesting. Gm square. If you remember the Newton's law of gravitation, it is Gm1 m2 by r square. So it's a force into r square, isn't it? This you can write like this. So Gm square is equals to Fr square, right? So instead of Fr square, I can write dimensionally. Okay, what I'll do first, I'll write the formula, then I'll write this substitution. So I can write this as H equals to energy into time, then KBT, which is energy, then T, and then this. So I hope this is easy to remember. So this is energy into time. So now we can write as energy into time becomes M L square T minus 1, and then we have KBT is energy. Then we have T as temperature, which is theta. Okay, this is confusing because I'm writing T there also, T here also, it's confusing. Force is MLT minus 2, R is L square. So now it's easy. Okay, M, then L cube and L4, L, then T minus 3, T minus 2, T minus 1. Is this the answer, guys, which you got?
No, sir. I got T minus 5. Rest is all same.
T L L L square, and this is L cube. So L square upon L power 4 upon L cube is L. Yeah,
So I got T different.
you got T different. You got
sir,
T
I got L different.
minus.
I got L different.
Sir, I got theta different.
You got T different. Okay, so everyone got something different. So that's interesting. But okay, are you able to understand this part which I wrote?
Yes, sir.
So just see it, and if you have doubt in this, then we can again go back and explain again.
I got the same answer after rechecking my answer.
Very good. So I think you need to try one more. Okay, then I'll go to the next topic. So this will be. hmm,
Sir, can you show the previous page?
Yes. Then
Yes, sir.
Sir, what is P?
I just wait. I'm such making a question actually. I always create a new question in class. Don't worry.
Sir,
So, yes.
no, sir, nothing. So I solved it early.
Mhm. Okay. This is the question.
Sir, what is P?
P is pressure. V is volume. Kv Boltzmann constant. T absolute temperature. G universal gravitational constant. UGC. H Planck's constant. R distance. I think I have mentioned all. You guys can go ahead and tell me now.
Sir, I had lost connection. Could you show me the answer of the previous
Previous,
question?
yeah. This is the answer.
Uh, yes, sir, I'd gotten the same one.
Very good, very good. So this is the answer, and now you can go to the this question. Try doing this question. The meaning of each term is explained below. So
Third.
I hope, yeah, I think someone is ready with answer. So got the answer? Or what?
Sir, I got M minus 2, L minus 2, T minus 4, I minus 1, and theta 0.
Okay, so what we can understand is the PV and KVT will cancel out because both are energy. So PV and KVT are energy. Energy upon energy is cancelled out. And then smartly we can do Gm square by R square because M square is not there. So I'll mention it as M square H. Okay, this is. Now we know this is like a force equation. So I can add force upon M square H. So I have reduced terms to very shorter small thing that we can know easily. This is MLT minus 2 and this is M square. And H is again famous. It's ml square T minus 1. Okay. Energy into time. So the answer is M minus 2 L minus 1 T minus 1. That's easy. Yeah, that's easy. Is this your answer?
Sir, H is T minus.
H is ml square T minus 1.
Okay, sir, yes.
Because H is like energy into time. Always remember energy into time.
Yes, sir.
Energy is ml square T minus 2 into T, then T minus 1.
Sir,
Okay.
but I don't understand how you got PV and KVT.
Okay, the dimension of the pressure into volume is always energy. Dimensionally, they are energy only. Okay. So because pressure into volume is having dimension of energy, KBT is also having dimension of energy. So two similar dimension will cancel out. So we are doing it dimensional analysis. We are not solving it as a numerical. So if dimension are same, I'm cancelling it. Okay. So let's say you have a 10 rupee note, I have 10 rupee note. So if we both have same amount, I'll cancel it. So it doesn't matter you have 10 rupee coin or I have 10 rupee a paper note. It doesn't matter. Okay. So you may have two 5 rupee coin and I may have 10 1 rupee coin. So at the end, if the values are same, I'm cancelling out. I'm assuming both are equal. But they are not physically equal, isn't it? Like pressure is pressure, volume is volume, T is temperature. That's a different thing. So any other having the same doubt? Why I cancelled PV and KBT? Anybody
Sir, but
else having?
it's the
Yeah.
potential difference, no?
Pardon? Yeah, I have written here V is volume, P is pressure, Kb is Boltzmann constant.
Sir, I'm having some connectivity issue. Could you explain this again? Why did you cancel that PV?
Yes, because PV having dimension of energy. What is pressure? Pressure is force upon area. Okay, and what is volume? So let's say if we have a cylinder of area A and height h, so volume we can write as A into h. So force and displacement is same as energy or work, right? Dimensionally it is same as work or energy or whatever. Okay, you haven't understood, right?
Yes, sir, I got it. I got it.
So always remember that pressure into volume is having dimensionally same as energy. In fact, you will learn later on in thermodynamics that the work done by gas equals to pressure into volume change. This is the work done by gas. This is what we learn also. So work having same dimension as pressure and volume difference. This is what we learn actually. So the heat engine works in this principle, right? In the piston and the cylinder, something like that is there. So okay, I'll move to the next concept actually. That's called the properties of dimensional analysis. Okay. So now properties of
Sir, do you have the JW question you said?
pardon, you were saying something?
Sir, you said no, that 3 years back that JW question. Do you have that?
Uh, you mean to say that dimensional question?
Yes.
No, that will do. That will do. After learning the property, we'll do those questions. Okay. Now, properties of dimensional analysis. There is something called addition rule, addition or subtraction rule. Okay, so tell me 2 apple plus 3 apple equals to how much? Equals to
5 apples.
5 apples. Very good. And then 2 apple plus 1 apple, how much?
3.
3 apple. That's nice. So you all know addition. And 2 apple plus 2 banana is how much?
2 common apple plus banana.
2 apple plus banana. You're saying this, right? Okay, so can we add apple with banana? That's the question.
Yes, sir.
Can we add apple with banana? That's my
Yes.
question.
No.
Can you subtract apple minus banana? Let's say I say 5 apple minus 3 banana. How much?
Sir, by count we can, but not physically.
No, what you can do then? So what is the meaning of 5 apple minus 3 banana? Does it make any sense?
No, sir.
You cannot subtract two quantities which are physically different. So in physics, you cannot add or subtract two physical quantity which are different dimensionally. Okay, so we can only add or subtract something which are dimensionally same, and that is the first stage of verification of a given physical formula. If a formula is dimensionally incorrect, then it must be incorrect. The other way is not true. because a formula which is mathematically incorrect may be physically correct. What is the meaning of what I'm saying? Let's say you know that what is the formula S equals to ut plus half at square. You all know this formula from
Yes.
kinematics, or you might be heard of V equals to U plus at.
Yes, sir.
Okay. Now, what if I make it half at? Will it make any difference dimensionally? Because number is dimensionless. So if you add or subtract or multiply a number to the existing formula, will it make dimensionally any change?
No, sir.
But still, this is not the right formula. So there is a way of saying it in physics. We say that if something which is physically wrong must be dimensionally wrong. But if it is dimensionally correct, then it may or may not be physically correct. So this is dimensionally correct because by dividing by 2, you're not making any dimensional changes. If I write this as 2u plus 3at, there is no dimensional changes. Dimension is still intact, but it is physically wrong. Okay. If I remove the half here, then it is physically wrong, not dimensionally wrong, because dimension is something different and a formula in physics is something different. So the rule says that the first stage of verification is if something is dimensionally incorrect, there is no need to check the physical correctness. If it is dimensionally incorrect, it means it is anyway incorrect. So physical correctness is only checked when we are through with the dimensional check. Got your point? So when something is dimensionally correct, then we can go ahead. So the rule says that you can add or subtract something which are dimensionally same. So only physical quantities with same dimension can be added or subtracted from each other. So for, let's say, if I write a question, distance or displacement equals to at plus bt square. Let's say a plus bt square plus ct cube, where a, b, c are constant and t is time. So let's say this is the correct formula. If I have written this formula, then what is already understood that dimensionally a must be same as bt square must be same as ct cube. All must be have same dimension, and all dimension must be matching with the dimension of LHS, which is displacement. So dimensionally, the a must be same as s. Dimensionally, bt square must be same as s. Dimensionally, ct cube must be same as s. So we can only add or subtract which are having same dimension, and because we are having equating with the s, so the dimension of LHS and the RHS must be same. So it should be same for individual and same for all also. So what they will ask you, find dimension of A, B, C. Find A, B, C. Can you guys tell me the answer quickly?
Yes, sir. A is meter. Sorry, length. 1.
Yes.
Then B is uh, length upon time raised to -2.
Yes.
Yeah. And C is L into T raised to -3.
Very good. So have you guys understood this part? This is not very difficult. So the rule is obvious that you can add and subtract something which are having same dimension. You cannot add something which is having a different dimension. So for example, if I ask you, can we add force with velocity? The answer is no.
No, sir.
because dimensionally they are totally different, so such addition will never take place. Can we add force with the momentum? No, because they are still having different dimension. Can we add mv by t?
Yes, sir.
Yes, sir. We can run.
Yes, this is correct. We can add something like this. Why we can add? Because the momentum upon time is having same dimension as force, because the rate of change of momentum is called force. So what essentially it is representing the rate, right? So
Sir,
you need
because
to
V upon T is acceleration.
pardon.
Because V upon T is acceleration and F equals ma. So same dimension.
Yeah. Yes, correct. So you can think in the way you want. So we can add only something which is dimensionally equal. They may look very weird as now, but if they are dimensionally same, then addition or subtraction is possible. You should not add something which is at first go dimensionally incorrect. So these are some stages of verification. Like we need to verify certain things, so we know that what can be verified, what cannot be verified. Now, the rule of multiplication or division, you can multiply anything. So multiplication. So you can say that you can multiply any physical quantity with each other. So multiplication or division of two or more than two physical quantities are physical quantities of different dimension is possible. So for multiplication, there is no restriction. You can easily multiply or divide. So for example, if we have divided, you can see we have multiplied m into v, which is totally meaningful, right? We know mass into velocity is for momentum, so it's a meaningful thing. And I can divide v by t. It's also meaningful. Everything is meaningful. And then the speed upon and distance upon time. So these are all meaningful things. So multiplication or division of dimensionally different quantities are possible. We can always do it. But for addition, the restriction is always there. And the third rule, every physical equation must have same dimension on both sides of equal sign. That is, okay, no, that is, this is called, this property. Keep on writing this thing because I think sometimes we may lose the sheet actually. This property is called principle of homogeneity. Homogeneity. Principle of homogeneity. So we are going to use this principle of homogeneity to derive some relation. Okay, so let's go next. Okay, so now do some example. Hmm. Okay, so tell me the dimension of Kc. So I think I have explained that all exponents, logarithms, argument or the values are dimensionless, right? So the power of any number is dimensionless.
Sir, but you said that C only single term C can have dimension, but
Yeah,
T
C
is to
will
be
have,
before that.
yeah, C will have dimension, but CT, the value, the product will have dimensionless. The net power is dimensionless, right?
Yes, sir.
So C will have dimension. That's why I'm asking it. So my question is find the dimension of Kc. So you have to find the dimension of K separately, C separately, and then do it. And K is not the power. K is a separate term. Think, guys. Think. It's very interesting. Think about this question. You will learn something new here.
Sir, but I'm getting minus
Yes.
equals to T minus.
C and K. You have to find the dimension of K and C. What is the answer?
No, sir, I'm getting minus.
Minus it will not affect the dimension. So minus can be minus only. So minus will never affect the dimension. We are only looking for dimension, not the sign.
Sir, ML3 T minus 3.
Just a minute. Once again, M.
L3 T minus 3.
Sir, I also got the same thing.
Okay, very good. So I think that should be the right answer. So first of all, what we need to realize, this entire term is dimensionless. Okay, so anything power is dimensionless. The entire term is dimensionless. This is a number. So power of a number must be dimensionless. This must be dimensionless. So dimensionless to the power dimensionless is dimensionless. So not a big deal. So if you make that term dimensionless, then C will have dimension of T inverse, right? That's easy, I think. So this part you all got. C is T inverse. Now the dimension of LHS and RHS must be same. That's the rule. So LHS is force and RHS is this into dimensionless. So just ignore dimensionless. So the dimensional is these two must be same. So we can say dimension of force must be same as dimension of K upon R square as a whole. Force though we know, and K upon L square because we know R is L. So that's crazy. So dimensionally K is how much? M L Q T minus 2. So I think you all got the right answer. So dimension of K is M L cube T minus 3. This is the answer you all got, which is absolutely correct. Okay, so next, let's try this next problem. Example 2. Okay, so this example is again interesting. This is called Wonder Wall. So the equation of the ideal gas equation, which you are already exposed to, PV equals to nRT. This equation is only true for the ideal gases which follows the ideal behavior. But in the real life, the gases do not follow this formula. So what they follow is called the van der Waals equation, which is a modified form of this formula, and it looks like this. So the P is replaced by this term. This is called van der Waals equation of gas. PV equation is P plus something and something. So I'll tell you what is something, something, something. So V is volume, P is pressure, N is mole, A and B are constants. So P is pressure. V everywhere is volume. N is number of moles. And T is temperature. A and B are called the van der Waals constants. So can you tell me the dimension of A and separately dimension of B? It's not very difficult, but it's interesting.
Hello, sir.
Yes.
Sir, please you'll explain again. I was lost somewhere.
So this is something called van der Waals equation of real gas or gases. So this equation is slightly modified version of the ideal gas equation. This is called ideal gas equation, which you will learn, of course, in chemistry very soon. So in this modified version, the P is replaced by P plus N square A by V square. V is replaced by V plus NB, and nRT is nRT. The meaning of all terms are written below. P is pressure, V is volume, N is number of moles, P is temperature, and A and B are called van der Waals constants. So the question is, can you find the dimension of A and B? That's it. I hope the question is clear to all of you.
Yes, sir.
Yeah, please try and give me the answer as soon as possible. Go ahead.
Sir, I have a doubt.
Yes.
Hello.
Yes, tell me.
Sir, can we add
Yes, tell me.
two entities, but one has constant and other one doesn't? So we can add.
Yeah, we can add anything, but when you add a constant, it means it's a dimensional constant. The constant can have
Like
dimension.
P plus and B like this. So can I add
Yes.
that number
So
of moles
V
in
is volume.
volume?
Yeah, V is volume, and NB as a whole will have same dimension as the volume, because we can only add dimensionally equal values. So N into B represents dimensionally volume, and that is why you're adding it. Okay. Remember the rule of addition. You can add two things only when they are having same dimension. So if I'm adding NB to V, then dimensionally they must have same value. And
Sir,
similarly, yeah, you got the answer, I think.
no, sir. I was asking that, sir, what we denote for number of moles?
Mole, MOL, it's a standard value, no? Mole.
Yes, sir.
So mole is standard value. It's I mean SI unit, amount of substance, which you know already. So MOL for mole. Okay, N is not a number, guys. N is number of moles.
Sir,
So that mole.
B is mole minus 1.
Yes, not tell me. You are saying answer for B.
Mole minus 1.
Mole minus 1. That's it.
Yes, sir. Means head M0, L0, T0, then mole minus.
No. See, the question is V plus NB. So we are adding two things. So both must have same dimension. Dimension of volume is same as dimension of NB. This is L cube, and N will come here. So dimension of B is L cube mole inverse.
Oh, huh, so sorry. I forgot to take the L.
Yeah.
Sir, can you
Now,
explain
yeah.
van der Waals once again, because I didn't understand.
No, this is just a imagine it's a formula given to you. No need to get into detail of what formula physically means or something. So imagine it's a formula given to you, and certain things are known to you as a dimension. Let's say you are very much aware of dimension of pressure, dimension of volume, dimension of mole. So using the properties of dimensional analysis, like what you can do, what you can't do, can we find the dimension of A and B? That is the only question I'm asking. Is it possible to find the dimension of A and B?
Sir, A,
Looking
I got M, L2.
just okay. Okay. Tell me what is we got A?
M, L2, T minus 2, mole minus 1, minus 2.
Okay. So I think this should be correct. So we have P plus N square by V square into A as a summation. So if we are adding these two, so they must have same dimension. So dimension of pressure must be same as this into dimension of A, which we are looking for. Pressure is force upon area. So okay, it's how much M L minus 1 T minus 2, right? This is pressure,
Yes, sir.
and
Yes,
mole
sir.
is mole square, so I can't do anything. This is L power 6 into A because it's a V square, so that's fine. So dimension of A I'm getting is ML5 T minus 2 mole minus 2. So there is slight change. I think you have missed this part, squaring.
Yes, sir. L volume square identical. So
Yeah,
it,
volume square becomes L power 6. So that's why dimension of A is this much. Okay.
yes,
So I
sir.
hope it's not very difficult. So anybody having this doubt, again you can ask. Pratiksha, you understood this part?
Yes, sir.
Harshit, you got it?
Yes, I was.
Atharv, Samant, and
Yes,
D.
sir. I got the answer,
Yes,
but I just got M0.
N0. That's M0. Okay. N is not 0.
Sir, I checked it. It was
Okay.
somewhere wrong. That's why.
Okay. Okay, fine. So let's do something new. Okay. So what question you can do? Hmm, okay. Let's see. Okay. We'll go to the next concept. Finding the empirical relation from initial observation using dimensional analysis. Now, every research, as I said, so when you do an experimental research, then you will come to know that of this particular physical quantity is depending on these various factors, and you want to know that how there is a dependency of these factor with the given physical quantity under investigation. So if we are investigating something and I came to know, okay, this depends on something, so there must be some empirical relation that we can easily deduce using the dimensional analysis, which will not be accurate, but it will at least give a glimpse of the dependency. Okay. So we further extend the research to derive at the actual formula, and various derivation in physics is started with this particular the preliminary investigation method called dimensional analysis. This method will use the concept called principle of homogeneity, and this principle simply says that the two things are dimensionally equal. Of course, if they are depending on each other, so there must be some sort of dimensional equality. So let's start something called application of the same. And what is in my mind right now is called, it's a very famous that you will also learn later on, and that is called Stokes law. This is a very famous law in a chapter of viscosity. Stokes was one of the greatest mathematician as well as physicist. He was both actually. Most of the people born in France or nearby Europe, they are mostly polymaths, so they love more than two subjects at least. They never stick to one subject. Like Bernoulli is a generation of mathematicians in France, and again they were mostly into mathematics and physics all the time. Okay. Sometimes in chemistry also. So Bernoulli is a family generation running the mathematical brand. Okay, so they rule the world of mathematics, and you will be surprised to know that most of the casinos are run by mathematicians. They use the theory of probability to run those casinos. Anyway, so what is this law all about? So I'll not go in detail. I'll give a brief history of the law. So what he did, what Stock did, he took a long jar filled with glycerine, and we all know glycerine is a viscous liquid, and then he dropped one steel ball. So he dropped one ball made of steel, and as the ball descended in the liquid, it gained velocity. But what was very important for Stock that he observed that after some time the ball stopped accelerating. It means after some time the velocity became constant. It was falling down and down, but with fixed velocity. And in physics, we say that is terminal velocity, and it's having huge application, be it the flow of various platelets or the RBC in our blood, okay, various bacteria in the body fluid. So all this follows this Stokes law. Apart from that, the dust particle which is suspended in air, they also follow the Stokes law. The raindrop which we have during rainy season, they also follow the Stokes law. So there is a huge variety of practical application where this law is applied, and it gives the limit of the velocity that something may be achieving in a certain setup. Okay. Okay. So what he realized that he said, okay, let's say we have a liquid, okay, in which the ball is, I mean, falling down, and this ball is having some radius. This is the radius is r. For a spherical object, radius is a sufficient way to explain every other feature, let's say surface area or volume. Everything can be explained in terms of radius. So radius is the fundamental thing for a spherical object. And then as it starts falling down, as it gains the speed, it experiences greater drag force. The drag is called viscous force. So from his initial investigation, he understood one thing, that the drag force or viscous drag force or drag. So when you try to move through the liquid, when this ball is trying to move through the liquid is offering a lot of resistance, and this resistance is called viscous or drag force. And this force he believed that is depending on certain quantities. So the quantities which he investigated and he believed that it's acting, he said that this drag force is depending on the coefficient of viscosity. Okay, it depending on the radius and speed, but he was not knowing the exact answer, like how it is depending. Okay, so when you do not know anything, okay, let's say in mathematics we don't know something, you say okay, let it be x. Okay, so in dimensional world, he was not knowing the exact power of these variables. So he assumed that, let's say, the force of viscosity depends on some power of eta, some power of r, and some power of velocity. In a way, it is like you want to construct a new dimensional quantical force using these ingredients. This is the ingredients, and using this ingredient, you want to create something called force. So force is like a recipe, and eta rv is like the spices, and a b c are like the proportion in which you must add to obtain this recipe. So a b c are called the raised power to the fundamental variables, and what a b c must be taken or chosen here to arrive at the new dimension called force. Okay, so we need to choose a b c to cook this recipe called force. So we don't know in the beginning what is the ABC, but we believe one thing, that if eventually it will cook up as a force, so that eta power A, R power B, and V power C eventually should give you dimension of force. So dimensionally, although I don't know the exact relation, but I can say dimensionally what FB will have is same as dimensionally what these three things will have. This is called the principle of homogeneity. We use it. Principle of homogeneity, I'm writing in short. I want to cook this recipe called force using the ingredients of eta RV. These are the spices available to me, and I want to make this force. Okay. So we have already derived the dimension of the three quantities on the RHS. LHS is known to you in advance. So how we proceed? So I'll write a force dimension MLT minus 2 and leave it. On the right hand side, okay guys, tell me, who will tell me eta power 8? What is eta dimension? Just check. I hope this is the answer.
Yes, sir. This is the answer.
And R will be L power B. And velocity we know, that's very famous. What is velocity? LT minus 1 power C. So what I did was I simply substituted the dimension and let the power be the way it is. So it is very easy now. It's like solving some simultaneous equation. So what we do is we first simplify the RHS. So I can see the power of M is only A. Can you tell me the power of L, guys? In total, what is the power of A?
Minus A plus B
Minus
and
8.
plus C.
Very good. And what is the power of T, guys?
Minus A minus C.
Very good. So on the RHS, we have this power, but on the LHS, we know the power, and the RHS, we don't know the power. So what we know and what we don't know must be same. So now something called equating the powers. What do you write? Equating the powers of LHS and RHS. What we can write, guys? See, 1, 1. So if you compare the power, what I can write? A equals to
1.
then I can compare minus A plus B plus C equals to 1, and then I can compare minus A minus C equals to minus 2. Because I know A, I can substitute in the last equation to get C, and I can substitute back in the middle equation to get B. Can you guys tell me A, B, and C value? A, so I know, so can you tell me B and C value?
Sir, A is 1, B is minus 1, C is minus 1.
Solve
Sorry,
carefully.
B is minus 2 or minus.
No.
C1.
C is 1, right?
The C is minus 1.
No,
C
so
is
I'm
plus
getting
1.
1, like positive 1.
Yeah, positive 1 is the right answer for C. So what about B, guys?
Sure, but where did you get the powers in the first place?
The power of M. So we compare the power of M here, L here,
Sir, B
L here,
So equal to
T
1.
here,
B
C
is
here.
also 1. So B is equal to 1.
Yeah, B is 1 is the right
So,
answer.
but we are assuming A, B, and C to be the powers of.
Yeah, because see, I had no idea what proportion I should choose, so I choose some random variable. So I just said A, B, C. I could have said X, Y, Z. Okay, so it depends on you what variable you want to choose. Conventionally, A, B, C is the very famous thing that we use in world of dimension. So you can stick to A, B, C, or if you don't like it, you can go for X, Y, Z. There is no problem. Okay. So eta RV is the spices, or you can say ingredients. The power is like the proportion you want to choose. and you want to cook a recipe of force. Okay, guys, so we got some answer. ABC equals to 1. So luckily, the drag force formula is proportional to this answer only. That's it. 8 RV. And then later on, after some experiment, we remove the proportionality with some constant K. And through experiment, the K was derived as 6 pi. And therefore, the formula of Stokes becomes 6 pi eta R. Okay, so this is the dimensional formula which we need in the chapter of viscosity. This is something which we learned there also. So I hope till that time.
I have a
Yeah.
doubt. So there is no way we can find out the value of K, right? That is, if we know, we can put it.
No. The K is mostly experimental. Of course, there is a well-documented research paper. I think I should have that paper. So in that paper, they try to derive it through some experimental and mathematical derivation, which is of course beyond the scope of masters. It's a part of PhD only. So there are some documents available on net. You can go and see it, which talks about how K is determined. Okay. So mostly it is because of the spherical shape. There are some differential equation which you need to solve to arrive at the answer, which is of course not in the domain of even master's level of learning. Okay. Yeah, I have that document. Someone gave me that document long time back. Yeah. So K is you need to understand K is determined using some experimental value. Okay, so it is derived experimentally. Yes. Any other doubt in this? Okay, understood, Pratiksha. Any doubt? Any more doubt?
No, sir, understood. Thank you.
Okay. So next is we are going to do some more research. Okay, let's say I want to create something already known to you, but with a new set of ingredients. Let's say you go to China and then suddenly you find that China is not using turmeric. So in their recipe, turmeric is not used, coriander powder is not used. They don't use garam masala and various things. And that is all actually that's a reality. They don't use it. So they use the green chili, ginger, garlic a lot. That's the ingredients of the Chinese recipe are different. So my question is, if I give you a new set of ingredients and I will tell you cook something more fundamental. So I'm trying to give you something called, okay, so this is my ingredients. Use force, symbol F, energy, symbol E, and time, T, as fundamental physical quantity and derive dimension of length and mass. So I give you these many things. These are like something fundamental to you. You have to cook these two recipes, length and mass, using these ingredients. Can you try this? This is of course challenging. You have to think about it and do it.
Sir, it is not compulsory to use all of them. No?
Sir, we
Pardon?
have,
Pardon?
It is compulsory to use all of them, or
Yeah. The length and mass is depending on these three fundamental quantities. They depend. Yeah, that's
so
known to us.
you have to use all three.
Yeah, you have to use all three. So if it is not depending, the answer will be zero. The power will be zero. If you solve it and if the power is zero, then you can say, okay, it is not depending. You gave me unnecessary. So you can blame me later on. So you start with, let's say all are part of the recipe. and the proportion you can choose A, B, C, and solve it. Even I don't know whether it will bring some answer or not, because I just cooked up this question in the class right now. So it's a very fresh question I'm trying to cook. So if it works, then okay, I will have a new question.
Sir, I got for length.
Okay.
For length, we have to, for finding length, we have to use only force and energy.
Yeah, you have to use force,
Energy by force.
energy by force. Is this the answer?
Yes, sir.
Yes, sir.
Yeah, quite possible, quite possible. So energy is, we know. Okay, it's very easy. Energy you can write as like force into displacement. So that's directly answer it. This is the right answer. It's very easy. And time, are we getting time from the same? Is time coming from this recipe or it's not coming? I think this is, yeah, this, sorry, mass. What I'm asking, mass. Is mass coming from this recipe? This
So
ingredient?
solving.
So,
Yeah, okay. Solve this.
no, sir, it cannot be.
It's quite possible. It may not come at all. So you will not get any solution to this question. So it means it's not possible.
So there is no mass formula.
Yeah, so leave it. So it's not possible. So not possible to cook. Derive from F, E, and T. Okay. So now I have some very foolproof questions which are very fundamental. So now let's say atom is small. Okay. So we know atom is very small. Then we discovered something called nucleus. So we said that okay, nucleus is the smallest thing. Then we discovered the elementary particles like leptons, gluons, or we will learn something more about this. Okay, so we have quarks, we have gluons, we have chlorons, flavors. So these are like something very fancy word in world of nuclear physics. So in the sub-elementary level, like when you go beyond the nuclear dimension, there are again certain things in the nature. So the question is, what is the smallest thing that we know in nature? So this investigation was very interesting, and everyone was trying to find the smallest possible thing which could exist in nature. Okay, so this was one of the most fancied derivation, and to our surprise, this can just be derived using dimensional analysis. So they try to define the smallest thing in the universe that can be measured, and they named it as quantum length. So there is something called quantum length, something called quantum mass, the smallest mass, and the quantum time, the smallest time which we can measure. And these three things, since as a part of nature, so they depend on the fundamental properties of nature. So three fundamental properties we came across. One is called universal gravitational constant, other is Planck's constant, and the third is called speed of light. So now the ingredients are this. This is your ingredient. And the recipe we have to cook. So can you cook the recipe of this and this and this using these three ingredients? If answer is yes, go ahead and start doing it. So the master chef, be ready. Cook these three ingredients to derive this recipe. So quantum length. Okay, I'll use quantum. Okay, remove this part. So you have to cook quantum length, quantum mass, and quantum time. Okay, so go ahead and derive it.
Sir, quantum length and quantum time can be given by only by power 1 by infinity or negative any number which is
Yeah, no. You have to choose GHC in the right proportion to derive it, and it will come. Don't worry,
okay, sir.
because you cannot choose infinite because you don't have infinite masala in your masala box, right?
Yes, sir.
So it must be finite. It must be finite. You don't say infinite.
Sir, for LHS, can we use direct formula from on length?
Yeah. Of course. It's a length only. Quantum is a name actually, but it's a length, mass, and time. So LHS is always L, M, and T for the respective values. Quantum length means the smallest length which is possible to measure in the universe.
So the C is speed of light की heat
Yeah,
capacity.
it's a speed of light. Okay, I should mention this. Okay, G, you know, H is Planck's constant, C is the
So for speed of light can be directly use velocity.
Yeah, for speed, of course, we have to use velocity.
Sir, I got off L length,
Yes.
which is L4,
Which is
L raised to 4.
no, L you have to derive,
Sir,
but you
L
have in
raised to
terms of G, H, C. What is the power of G, H, and C? What is A, B, C? Let's say if I say G, A, H, B, and C, C, then what is A, B, C value? Because this is should be dimensionally L, right? For quantum
Sir,
length.
I yes, sir. I multiplied into 3. Then my dimension is M0, which is uh,
What is the dimension
L6.
of what is the dimension of G?
G is M minus 1, L3 T minus 2.
G minus okay. M minus one, L, T,
L3
T,
T minus
T minus two. H is okay power A.
2, T minus 1.
M L minus one, T minus one. Sorry, M L two, T minus one. Oh, M L square, right? So H is M L square T minus one, right?
Yes, sir.
And C is L T minus one power C
Yes, sir.
equals to L. So the total power of M you're getting is minus A plus B. That's it. L is 3A, 2B, and C, and T is minus 2A, minus B minus C, and that is L. So if you compare, minus A plus B is 0. So A equals to B, that's for sure. And 3A plus 2B plus C is L, 1. This is 1. And minus 2A minus B minus C equals to 0. So you have 3 equations to solve. So,
Sir, I got the answer for length.
so what is ABC? First tell me.
Sir, A is 1 by 2, B is 1 by 2, and C is -2.
C is -2.
Yes.
Okay, fine. C is -2. Okay, no problem. So we can write quantum length equals to proportional to G H under root
Sir, A is
upon
1 by 3.
A is 1 by 3. Okay. So B is also 1 by 3. Okay, guys, you guys first solve and then tell me because I think something is wrong here. Solve this carefully because this is slightly complex to solve. Not very difficult. Just solve it properly.
And sir, C is -2 by 3.
Yeah, that is correct. I think that looks correct. What is A and B then?
1 by 3.
Yeah, that looks fine, I think. So A is 1 by 3, B is 1 by 3, C is -2 by 3, right?
Yes, sir.
Okay, so I think that looks correct actually. A equals to B equals to 1 by 3 and C equals to -2 by 3. So the quantum length is proportional to, okay, GH by C square power 1 by 3. Then this will become the formula, right? Okay, this is the initial investigation value.
So
Anybody
what
else
are
get it? Yeah. Tell me. Come on, guys. You have to solve for A, B, C. That's not very difficult
so how quantum length is proportional to GH upon C square is to 1 by 3.
because that is what we started now. We assume that because we don't know the answer. So let's say quantum length is proportional to G per 8. So we got the value.
Yes, sir, understood. Yeah.
Yeah. 1 by 3, 1 by 3 minus 2 by 3. So that's why we can write like this. Okay. In fact, the GH by C square power 1 by 3 itself is the quantum length. And the value of this length, if you find, so actually this was found to be equal actually. This was taken as equal only. I'll tell you the exact answer for this. Like in terms of proportion, this is 6.67 minus 11, value of J is 6.626 10 to the power minus 34. This is 916. So roughly it is like, okay, like 40 something. Okay, anyway, just look at the power, something into 10 to the power 34, 35, 45, and 51, 61 minus 61. That is tremendously small value. So
Sir,
this
can
is
you
the
solve this one because I can getting 1 by 2.
okay. Then don't worry, I'll solve it. I will solve, no issue. So this is roughly 5 into 10 per power minus 61. So see, this is the smallest possible value that you can measure in nature, which is for your surprise, this is smaller than oh my god, anything known. Okay, this is very small. Okay, it's difficult to explain how small is this number. We can only write it. We cannot feel it. Okay. Okay. So okay, you are asking how the formula came. G A H B. Okay. So okay. So I have solved already. Minus A plus B is 0. A equals to B. And we have next question. minus 2a. This is the last question. I'm using the last question first. So I can write a equals to b, so I can write minus 2a, minus a minus c equals to 0. C is minus 3a. So we got a equals to b, c equals to 3a. Solving this and this. And the last question is 3, 2, 1. So this of 3a, b is a1 is a 2a, and c is minus 3a. So it's 2a. Come on. A is 1 by 2. So you
So
someone
that one, yeah, I said 1/2.
yeah. So 1 by 3 is not the right answer. Maybe something is wrong here. Minus 1 may be the answer. Let me check. So A is okay. So we got A. So we got B also. This is equals to B, and C is how much? Minus 3 by 2. So the quantum length is proportional to G half H half C minus 3 by 2. So basically this is G H by C cube under root. This is the answer. Because this is the right answer, I think, because minus 41 should come as the smallest value, because that is what I remember one time back. I did this calculation. Just a minute. This is also wrong. So this is wrong. Okay, so this is the right answer. And if you solve, okay, fine. Minus 61 power 1 by 2. Yeah. So okay. Okay, 2.2. Yes. Okay, so around 30 something. The order is this. So roughly 10 to the power minus 30 is the smallest value. This is the smallest length you can measure. Okay. So I think you can also derive similarly quantum mass, so that I'm leaving as a homework. You guys can do quantum mass and quantum time. Okay. Okay, guys. So I think this is sufficient. And we have done the dimensional analysis part. I think you all have received that book which I shared yesterday, the Universal Self Scorer. USS you all have.
Yes, sir.
So if you open the chapter of unit and dimension, did you open yesterday? No. So unit dimension is a far away chapter.
Sir, for this chapter, we have to refer to NCRT.
Uh, no, you can do
We
it.
have to read, I mean, we have to read NCRT.
No, there's no need to read. Now you have to just solve the question. You have learned everything. So, okay, I don't know. This chapter is in this chapter. It's just student. Surface tension, simple hand motion. Okay, that. Chapter number 1, 2, 3, 4, 5, 6, 7, 9, 10. Just a minute. Okay. Then I'm not finding this. And okay, I'm not finding this chapter in this book. I don't know. It's written, but I don't know where they have mentioned this.
Sir, could you check page 44 in the PDF if that's what you're talking about?
Page 44.
Yeah,
Yes, sir.
in the USS, right?
Yeah. Okay, just a
Yeah, it
minute.
says units, dimensions, and measurements.
Yes, yes, right. Okay, I was looking for 700 pages. Okay, fine. So now this is the page. Okay, I was looking for. Yeah, that's correct. So in this chapter, we have ordinary thinking. Then we have something more, dimensions. Yeah. So you have to solve only two parts. Unit part. If you look at under the heading units, solve that part and then dimension. Because the error part is not going to be covered here. We teach error at the end of the syllabus because by that time you will be knowing all formulas, all theory, and then error will be meaningful. But still, I will teach a small concept of error here also, which will not be exhaustive, but it will be just a beginning of error and error analysis. So from this chapter the page 44, which you just investigated, solve all question of dimension. I think this is complete package and enough question is given, sufficient to practice.
Sir,
So
can you
you'll be
repeat where the questions are?
questions are from, just I will tell you. It's question number
Sir, page number.
page number 50. I do not go. Yeah, it's 51. Okay. Like in the PDF, it's 49 page, which in the book number page number is 49. And just above you see dimension. They have written dimension. You can read at the bottom of the page, and they have written units in the page number is 46 of 45, 44. Yeah, yeah, 44th page. Yeah, correct. So from 44 page, you have to solve till 44, 45, 46, 45, 47, 48, 49, 50. It's very easy. You can do it quickly. It's few seconds. Okay. Okay. Till question number 142. 142. From dimension 1 to 142, complete the full dimension, full unit. So it's 109 questions of units. and 142 questions of dimension. So don't get intimidated by the numbers. It's a very small number, but it's just like tick. You know the answer. Just tick mark. So this is your homework. Okay.
Sir, can you repeat it?
Yeah, page 44. You
Sir,
can
in
read.
PDF it is 47.
Yeah, PDF not. I'm saying I'm the book page number 44 of the book.
Sir,
If you look, no,
sir, we have to read the whole content before solving.
no. You can directly solve. It's easy.
Sir, because I have
Yeah,
seen
yeah.
questions.
You have to read. You have to read what I have taught you. That's it.
Okay, sir. So there are
Yeah.
conversion also there. Conversion questions like which conversion is wrong. So there is 1 calorie, and 1 joule. So
Yes, yes. So that you know in class 9th, na? 1 calorie is 4.186
yes, sir.
joule. Okay. So solve question of units and dimension. If okay, whatever doubts you will have, of course, you will have some doubts. So those doubts is will be the part of the next lecture. So you have to discuss all doubts by next lecture. If you fail to do so, then the chapter will not be discussed in the class. You may have to ask in some other class. Okay. So make sure that you finish the homework by next lecture. It's not huge homework. It's pretty easy actually. You have to just go through it. The moment you see, you know the answer. So that's like 1 second will take for one question, that kind of thing. So all got the page 44. Page 45, page 46, 47, 48, 49, 50, 51, 52, 53, and 54. 55, sorry, 56. That's it. 56 till the dimension part 142. So have you all made the note of it?
Yes, sir. Sir, what is
Yes,
Stephen's
sir.
constant?
Pardon? What
Stephen's constant.
is Stephen's constant? Okay, did I miss it? Yeah, I missed it. Okay. So leave it. Okay, I'll do in the doubt class. But anyway, it's very easy. Stephen's constant has come from the word, I mean the chapter of heat only. It's epsilon sigma. Okay, so you can ignore everything. This sigma is called Stephen's constant. This is like power. This is area. This is temperature. This is dimensionless, called emissivity actually. It's dimensionless. So rest you can derive, right? I hope you can derive from it. So this is part of heat and thermo only. I missed actually. So good you remind me. Okay, so this chapter is almost over. Next class will be doubts and discussion. In the doubts and discussion, I'll add up a small theory of errors, because error itself is a very big chapter, but error is not taught completely at once. It's taught in two phases. So right now I will teach you error because so that you have the basic idea, and then the advanced error analysis will do at the end of the complete syllabus. That's done separately. So okay.
Sir,
So yeah,
sir, please can you explain heat combination in short?
which one?
Uh, heat capacity. Sorry.
Yeah, heat capacity. Heat capacity is just you have some substance. You will take some water in some vessel, put on the gas stove, and then take a thermometer attached to it and check the measurement, that what is the change of temperature and how much energy you have supplied. So how you can find it? Let's say the flame is burning at some rate, so you know how much energy you have supplied. So if you know the energy supplied, dq is the energy supplied, which we write in heat chapter. Energy supply, and then you can check the change in temperature. The ratio of the two is called heat capacity of this entire substance taken together.
Sir, dq by dt is power, no?
Yes, the small time is power, but here temperature, so it's not power. Okay, here T is temperature. Oh, I think I got your confusion. So T represents time and
Just
capital T is temperature. So dq by small dt is power, but dq by capital dt is nothing. It's heat capacity. Energy upon temperature, dimensionally energy upon temperature. Okay.
Okay, sir.
Any other doubt? Anyone?
No, not us.
Okay. Okay, fine. So I will end the lecture today here only. And
Sir, DE also is
yes.
energy.
Pardon?
DE also is energy.
Yeah, D is energy. See, in different context, you need to understand what the symbol means. So sometimes we use DE as energy also, DQ as energy also. Sometimes I take DQ as charge also. So it's depending on chapter. Okay.
Okay, sir.
So the see, you guys have same name Atharv and Atharv with a different surname, but Atharv
So
is
I'm
not
Harshit.
reserved. Pardon?
I'm Harshit.
Yeah, you are. So I'm saying there are two guys in this group with the same name, same initials, I would say, but still they are different persons. So same symbol you will see in different chapter, but the meaning will depend on the context. You cannot say that this meaning must be same for all chapters. You can't say like that. Okay,
Okay,
fine.
sir.
So please do practice the homework. Okay, don't take it lightly, and from here try to build a momentum and try to keep that momentum till future. Okay, guys, bye and take care.
Thank you, sir.
Happy learning.
Thank you.
Yeah.
Yes, sir.